let's take a look at 13.2, number 31, and it's got two curves that intersect at the origin, and we need to find their angle of intersection to the nearest degree. So the first one that we're given is t squared, and t cubed, and the second space curve that we're given is sine t sine 2t, and t. Got a little extra tick mark there somehow. What was I thinking? Alright, so what's our strategy going to be? Well, if you remember back to section 12.3 on dot products, if you knew, if you had two vectors, then you could use the dot product of two vectors, and the angle of intersection would be the inverse cosine of the dot product between two vectors. But we don't exactly have two vectors yet to execute this dot product. So what I'm doing here is I'm kind of reasoning through the plan from thinking about some big ideas that relate vectors and angles and all this kind of stuff. So how would we use this as a building block? What other inputs would we need? We've got two space curves. They're intersecting at the origin, and if we had tangent vectors to both of them, call them V1 for this tangent vector and V2 for this tangent vector, then we'd have vectors to work with. Now we could use the more detailed ideas of the section, and we could get unit tangent vectors. But here we don't actually need unit tangent vectors because the magnitude of the vectors appear in the denominator of the formula anyway, so we could use unit tangent vectors, or we could just use tangent vectors. And when you differentiate a space curve with respect to time, you get the velocity vector. And the direction the velocity vector points is always the direction that you're going at that moment in time. So the velocity vector is conveniently tangent to the space curve. So V1 is going to be the time derivative of R1, and which is just component by component. The time derivative of t is 1. The time derivative of t squared is 2t, and the time derivative of t cubed is 3t squared. Now we want a vector that's not changing its direction, that's just pointing in the same direction at that moment in time where the intersection happens. So we need to back up and say, okay, at what moment in time is this space curve at the origin? Well, that's pretty simple. If you plug in t equals 0, you get 0, 0, 0. So you can see that the moment of interest is t equals 0. So V1, once you evaluate it at t equals 0, is 1, 0, 0. V2 now, and it's important to differentiate first and then to substitute in t equals 0. Because if you substitute in t equals 0, then you have a constant vector here, and then when you differentiate it, the derivative of a constant is always 0, and that's not really right. That's the wrong order of things. So taking the derivative of sine t, sine 2t, and t, we get, well, the derivative of sine is cosine. The derivative of sine 2t is 2 cosine 2t, remembering that the 2 pops out because of the chain rule, and then the derivative of t is 1. Now evaluating it at t equals 0, cosine of 0 is 1, cosine of 2 times 0 is still 1, but times 2 is 2, and then 1. Alright, so we have V1, we have V2, and now we can go ahead and find the angle. The angle is the inverse cosine. Well, let's go ahead and do the dot product and the magnitude separately, and then we'll plug in V1 dot V2 is the dot product, so it's 1, 0, 0 dotted with 1, 2, 1. And what does that work out to be? Well, it works out to be a scalar, first of all, so let's get rid of the bracket notation at this point. 1 times 1 is 1, plus 0 times 2 is 0, plus 0 times 1 is 0. So the dot product is 1, so we can put 1 in our numerator. And then what's the magnitude of V1? Well, the magnitude of V1 is the square root of the x component squared plus the y component squared plus the z component squared. So that's just the square root of 1, which is 1. V2 is the square root of 1 squared plus 2 squared plus 1 squared. So that's the square root of 6. So we have 1 times the square root of 6. So the angle is going to be the inverse cosine of 1 over the square root of 6. And we need to take some care here, because it says find the angle of intersection correct to the nearest degree. So a couple of details to be careful with. First of all, you want to make sure your calculator is in degree mode, because when you take the inverse cosine of the 1 over the square root of 6, that'll return the answer in degrees, and then you simply round to the nearest degree.